Alright, so we'll go on and do these so we can get started with those prefixes that I gave you. I want to make sure we hit those prefixes. Give us at least 3 sets of naming rules. Do this really well. Alright, so up here, up top, you look at it. What is the cation? Cobalt is a cation. Now, what's special about cobalt?
It's a D-block dude.
He's one of those D-block dudes. So what set of rules you use with the D-block dudes?
D-block.
Stock system. So in this case, we got to find the charge of this cobalt so we can find it to put it into a Roman numeral in parentheses next to the cobalt so that we'll know the charge. So in this case, best way to do it, nitrogen, or nitride in this case, has what charge on it? -3. Okay, so -3 and 2 means -6. This has got to equal a +6, and how many of them we got? 3. So 6 divided by 3, 2. So it's got to have +2 charge.
So it'd be
Or
cobalt.
you can just reverse it.
No.
When you write it.
Whatever you do with the numbers, is it always
Roman
that
numerals
just reverse it?
The problem of it is you can't always reverse. Like I think we did calcium oxide yesterday
Maybe.
because calcium has a 2+.
Yeah, we did.
And oxide has a 2-. So it's a 1-to-1 ratio, so it's CaO.
Okay. So as long as it's not like the same number.
Yeah.
but opposite.
Then it works. What's the charge on nitride? How many of them are there? So -3 times 2.
Is the only case where you can't switch it is like with they are the same number?
Yeah.
And then they cancel each other out?
Yeah. Stuff on charge.
Like iron 2 oxide. It won't work. But iron 3 oxide, it does work. That's where I like to show multiple different ways so that you got a full set of argument. Okay, so we found the charge of it. It's cobalt 2. Then we name the anion, nitride. There's the name. And remember, the reason we don't put a charge with that nitride is because it comes from nitrogen, which is in the 15th column, which has a fixed charge. It will not change. It will only carry 1 charge. Then comes this one, NiP, NiP. So whenever you're talking about NiP, first thing you got, Ni, which is what? Nickel. We got to find the charge of nickel. So in this case,
It'll be 5 to cancel out the phosphorus, right? Would it be nickel?
what's the charge on phosphide?
It's -3. Crap, I'm doing. I don't know why.
-3,
I
there's
know why I
1.
said 5. I know I said 5.
So that means the nickel's got to be a plus,
I'm not done.
has to equal to a +3. There's only 1 of them, so 3.
I promise I'm not done, Mr. Paul.
I know you're not. You just get flipped up. You figured out how many valence electrons there
Yes.
were.
Why did I have to do it?
To cancel out.
Because phosphide is -3.
Yes, I'm saying, yeah, you definitely are.
Yeah, they got canceled. Or find themselves to be equal.
No, that's
Phosphide. Hopefully y'all are catching on to this a little bit. Let this one down here.
Sodium chloride.
I gave you this obvious one for a reason. You have learned 2 sets of naming rules to where you have to determine what set of naming rules you have to use. Should you use the stock system here?
No.
Why not?
Because it's not a D block.
It's not the D
You have
block.
an anion
It's not a D
cation.
block dude. It's in the alkali metals. It's in the first column, which means it'll carry a +1 charge always. So you just name it the cation, which is named from the element sodium, then chlorine, which remove the ending, add IDE, so sodium chloride. Questions there? No? Okay. So right here we got copper 2 phosphide. This is the thing here. We're going from the names back to the chemical formulas. Remember what I said to do before? We're going to write down the cation and the anion. So I have copper. Got a +2 charge. Phosphide comes from column 15, which means it has a -3 charge. In this case, they're not the same charge, so we can cross. So Cu
I want
3
CU at CU.
P2.
I get so many emails
From them that says
that
that.
I will see you, but see you.
Okay. Questions on that one? So everybody's getting this, or they're just to the point you're like, maybe this will eventually click. I'll just wait out and see. All right, so we got iron 2, so Fe 2+, and bromide. Bromide comes from bromine, which comes from the 17th column, which has a -1 charge. They're not the same charge, so we can just cross them. So it's FeBr2. Iron 2 bromide, FeBr2. And then here's a dead giveaway for you. There's no Nomen Rumal. Nomen Rumal. It's literally just what came out of my mouth. How did that just happen? Roman numeral. There we go. There is no Roman numeral, therefore, this is not one of the D block dudes. It's a dead giveaway. When you got the name, you don't see the Roman numeral, means, hey, not a D block dude. So, sodium comes from the first column, so a +1 charge. Nitride comes from nitrogen, which is in the 15th column, which means -3 charge, not the same charge, so we can cross them in a 3N. Woo!
Woo! I just said hi.
That's how I get whenever I like the morning that I was driving here Monday morning. It's like we're starting nomenclature. I'm like, "Arr."
Yeah, I get to see
That's a normally weekly thing for me.
you.
No, I did talk to my wife where she's working on a degree in education now. I said, see, this is funny. You're going to teach them like little kids. She wants to teach 4th grade. I said, they're going to have you and then come to me and they're going to look at me and say, your wife was an angel. You're the devil.
And since you have 3 cobalt,
Because my physics class, and if you don't believe me, you can ask them. I really did do this. I gave them their last quiz, and a girl looked at me as I looked at it, and I just said it now. I didn't even make a face. I just looked at it. She starts crying.
that's your tolerance because it's D block.
And so it's like 5 minutes before the class is going to leave. And somebody else said they're about to cry. So I walk over on my desk, I pick up a box of tissues. Right there where Angela's sitting, I set the box of tissues. And I go,
It's not by itself.
in case you need these on the way out, you just grab a few.
Wow.
The
It's not
audacity.
disrespect.
That is
I'm
very much-
preparing you.
Mr. Hall,
That is very
Ivory is
much-
going to come to you at lunch today.
Awesome. This is the thing. This is my goal. This is my I'm being truthful with you. My true goal is when you get to college and you take your first chemistry class and you go in there and that professor is just rolling down and everyone else in the class is freaking out and you just look and you go, it's the best you got? This is it. I survived Hall. If I can survive Hall, I'm gonna ace your.
I have a question. I have a question for you. Do you know Seth Floyd?
I do know Seth Floyd.
Awesome.
I actually student taught under him.
Yes.
He is a legend. Me and him sees very, very eye to eye in things, and he is a dear, dear friend.
My cousins had him for chemistry at Covalent.
He is a legend. I'll tell you that right now.
Because we were talking about y'all the other day, because they came down from Huntington for my little brother's birthday party. And I was like, you know, in chemistry, awesome. I love it. It's amazing. And then I mentioned that I knew, because you talked about it before, that you had done your statistics at Cal Midland. And they were like, ask him if he knows our chemistry teacher, Seth Floyd. And I was like, okay. I think
Oh,
I
know the Floyd.
Yeah.
The Floyd is legit.
Yes.
See, Floyd, he mentored me a little bit to give the tricky question that is going to like rock and roll students, but will prepare them for whatever comes at them.
I swear.
So,
Quick question.
yeah.
Send me a
Do I have to
room.
like use it, like if I want to major in health science?
What do you want to do with health science? No.
You're going to be an aerospace engineer.
All right.
Yes, sir.
So, now, I have been nice enough to you that I printed this out for you.
Thank you very much.
I gave it to you from the kindness of my heart. There's a little sliver right here in my heart that has kindness in it. And I said I should print it and not make them write it down. The truthful, I did that so we didn't have to waste a lot of time with this. And you always have it handy for yourself. Now, I will be honest with you.
You must memorize it.
Will you be able to have this paper out for your quiz?
No, you have to memorize it.
No, you ain't gonna have this out for your quiz. You gonna memorize this stuff.
And then you
I've already done it.
How do you say the one for non? Is it like
Yeah, I've already
non?
got it memorized.
Nana.
Nah, how do what now?
I feel like I'm German. Nana.
That's
I was
not,
saying,
that's
like,
Spanish
non,
after
and I
all.
was like, that sounds like Spanish.
You mean nine?
Yeah, I was like, and then she came like,
All right.
I see what you did there.
So in this, you got the prefixes. I don't have to give you the prefixes, but you need to learn how you're going to use these prefixes. So this is the thing. Look what we've done so far. We've dealt with ionic bonds. Within the ionic bonds, you have to find yourself whether you're dealing with the cations from first, second, or 13th column, or if you're dealing with the D block dudes. Either way it goes, you got to know what you're dealing with. Now we're going to go into the second type of bonds we talked about. The covalent bond. Now within this, whenever you're dealing with the covalent bonds, what you're literally going to find yourself encountering and having to deal with is using these prefixes. So here's what we use the prefixes for. We use prefixes to represent the number
Hashtag.
of that element in the molecule.
so like whenever
So the college
like so
professor.
Yes, but we wouldn't do sodium dichloride. It would be like carbon dioxide. But you're on the right track.
In college, do they like not more like you do, or do they just say it and you have to?
Depends what professor you get.
Most of them just give lectures. Some of them go through the
I had professors that would come up right on the board. in lecture with writing on the board. Then I had a professor that, this one really sucked. He was my Organic 2 professor. He walks in, writes a molecule up on the board, draws an arrow out to it with a question mark, and he turns around and says, so we're starting with this molecule here, and we need to turn it into blah, 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 blah. Now, there's many different ways that you can do this, and he just talks to us the whole time. And it's like you're trying to get everything that you want to get. And then had another professor that, she was probably my favorite. She did PowerPoints, but what she did is she sent you the PowerPoints and told you to print them out and just hole punch them, bring them to class, because she's going to use those PowerPoints, but she's not going to use the PowerPoints and read from them. She's actually going to teach from them, and she did, which went great for us. Like, she could spend 2 seconds on a slide, or she could spend 15 minutes on a slide.
Could you like take your phone out and like get on the listening mode and record the lecture, just in case you miss something?
Certain ones have certain standards. Like, they'll look at you and tell you, if you want to record the class, you need to ask my permission first. Like, they want to be aware that they're being recorded.
How would they know that if I have my phone face down? Just their voice.
It's kind of illegal if you don't.
Yeah, it's illegal if you don't.
Like, okay, there's a difference between in college and in high school. In college, that professor's going to walk up to you, see your phone, and tell you to turn it over. I think you're recording me. And even if you're not, and you say, I'm not recording you, he can say, you just called me a liar. Get out of my class. And you're kicked out. It's a totally different world. And that there is no, like, this credit recovery stuff, all that goes away. It's straight up in your face, real deal, nothing playing around. This is what you get. It doesn't matter. If you come in and you studied your butt off and you bombed that quiz, you bombed it. You can get your parents to call as much as they want. That professor ain't going to change nothing. Because the truth of it is, you're paying to be in the class. He doesn't care whether you pass or fail. Because if you fail and you still want to stay in that field, it means you got to take the class again, which means more money.
Well, most of them like let you record.
It's just down to that professor. I can't look at you and tell you whether they will or not. You just need to ask them.
Did they let you?
I never did. All right, so in this, there is some keys, okay? I want to make sure I stress this to you. This key is for mono. Now, when we're talking about mono, we're not talking about the kissing disease.
Mononucleosis.
Okay? So don't nobody go out here and say, we talked about kissing back in my chemistry class. That's not the type of chemistry we talk about in this class.
We talked about 14th yesterday.
Shut up. All right, mono, as you can see off there, is being used for one. This is the key, though. For the first element.
Use number 1.
For the first element, you will never use mono.
Like carbon monoxide.
Exactly.
So that's good. And you'll never use it on the
Never for the first one, and this is as to why. If you're saying the element's name, it's understood there's one there. Now for the second element, you will always use mono. The second element will always get a prefix. The first one will always get a prefix unless it's one, and you will not use mono. Never use mono for the first element. Have I made myself clear?
Sure.
Now, we go into the fun. You'll get a feel for this. Pretty much you see those O's and A's in parentheses. Pretty much you're just avoiding double vowels back to back. So it's not monoxide, it's monoxide. Okay.
Monoxide.
So in this, whenever you're naming these covalent bonds, the second one stays the same. So the second element, as you're used to, you will first give the prefix. Let's say proper prefix. You will always give that proper prefix in there. It's required, it's necessary. You got to be telling them mono, di, tri, tetra. Every one of them, you've got to tell me because it's telling me the number there is. And then second, you will give element name. And you're already used to this. Remove the ending. Add ID. All right. So you're pretty much used to this, okay? And I'm gonna be completely honest with you. These are easy when you're going from the name to the chemical formula, because I spell it out for you. If I put dinitrogen pentoxide, di is 2. Let's just do it. So dinitrogen pentoxide. You're literally, it's all spelled right there for you. These are the simplest ones that go from the name to the chemical formula. So N, di stands for 2. Oxide is oxygen. Pent is 5.
Because oxide is 8. And his
That's interesting.
with all of these.
This is where these things get tricky, is when you're going from the chemical formula to the name. Reason behind that, if you do not remember the prefixes, then you're hurting right off.
They
Okay.
don't learn this in like kindergarten, like
Prefixes.
like orthogon, hexagon.
It's pretty much coming from the same thing. So like for example this is P4O10. This is where things can get difficult. This is why it can get difficult. You have to notice what set of rules to use. Okay, in this case, we're talking covalent bonds. What are covalent bonds?
Don't ask me, Mr. Hall.
Whatever that
Bonds
is.
that.
'Cause I cannot tell you.
Bonds that bond, yes.
Bondy
metals
bonds.
and metals.
Non-metals.
Non-metal
And
and a
non-
non-metal, or non-metals.
The way you just did that, Mr. Hall.
So in there, I need a periodic table where I'm going to spell phosphorus.
There's something.
I need something close to my eyes. I'm old.
PHOSPHORUS.
Congratulations, you can spell.
Yeah.
I'm not in Miss Debbie's English class. Alright, so in this case, P4O10. First element, phosphorus. Write the element name down. You got to put the prefix with it. Why? Because there's a 4.
Because it's not mono.
Because it's not mono.
It doesn't have mono.
Okay? So tetra. Tetraphosphorus.
Whoa, 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 whoa. Why wouldn't it be that?
Because the 4 does not go
Those
with
4 is not 10.
Wouldn't make it go with oxygen?
Well,
Yes,
I know that, but I'm just confused because of the switching thing.
No, you don't do the switching.
Don't do switching thing. Different set of rules. This is covalent bonds. Covalent bonds, you literally look at it and work back. Then from here, 10 is dec.
Mr. Hall.
If you want to, you can do the deca. But then when you look at it, you say, oh, it's oxygen. So deca oxide? That don't sound right. Dec oxide. Tetraphosphorus decoxide.
I was listening to this, and my mom could hear it. I was watching my YouTube videos. She said, is that our language? Is they speaking foreign? Like, she was dead serious. No.
That's great.
She give me some, tell them I'm speaking Latin.
Mr. Hall,
We
I
have a
hope
line.
there's been a profound thing that's just happened in my head. The difference between covalent and ion. It finally clicked.
Thank God.
And I couldn't have, like, for the life of me, I
What
couldn't
is a
remember.
covalent bond? I don't know. They asked me what's wrong.
Wait, what's the-
Oh my gosh,
No,
why didn't you say that
no.
before? Yes! I finally understand.
Yes, that's basically what happened in my head.
It's like he's
Accurate?
having
Ionic
he's
bonds,
having an
metal,
elf
metal.
Santa moment.
No.
Wait, so ionic is metal and non-metal, and covalent is non-metal, non-metal?
Yes.
God.
See, at least I'm not the only one.
That's true. All right, so you see how simple these are, right?
Sure.
So let's get y'all some practice in.
Hey. Oh, so we're doing CO3?
Whoa. So we don't do the switching thing with
No,
What kind of
because
bond?
do they carry charges?
covalent. So with ionic, we do
The switching.
switching thing.
Yep.
Okay.
I don't know if that last one actually exists or not, which you'll find out in this. I don't know if a lot of these are existing. I just put things together.
And they work, so it's okay.
Hey, fits the bill.
That's right. If the shoe fits, Mr. Hall.
Hey,
This one is easy.
can that kill you?
Carbon dioxide?
Yes.
Yeah. If that's all that you got around you to breathe, then it's not really carbon dioxide killing you. It's more of a lack of oxygen. But yeah.
Can carbon monoxide?
Yes, carbon monoxide kills you because of the size of the molecule. Carbon monoxide, so CO, is smaller than oxygen, which you know is O2, so it's smaller. So on those iron molecules within your hemoglobin, myoglobin, what will happen is carbon monoxide will bond and it won't release. So the oxygen can't bond to it to carry throughout the blood system to get to your organs, so they don't have oxygen to carry out cellular respiration. Cellular respiration can't take place, they run out of energy. Next thing you know, organs start shutting down, and you.
That's a big boo.
And you're dead.
Do you have to change the suffix of the first element whenever it has a prefix?
Yeah.
No, no. First element, you will not change this.
I like these a lot better than my
tell Mr. Hall. You know what I like?
Mononucleosis.
Something oxygen probably has.
Alright, so let's go through these. CO2, you guys already know it, but I want you to work through it. So C is carbon. There's nothing there, which means there's a 1, so should I put mono? No. Just carbon, okay. 2 is di. And oxygen is oxygen, remove the ending, IDE, so carbon dioxide. You're learning how to name things, I'm so proud. This one, same thing, carbon.
That actually.
Somebody said tetra.
Carbon tetrafluoride is a thing, isn't it?
Yeah.
Do you know what that's used for?
I can't remember if it was carbon tetrafluoride or carbon tetrachloride that G had sent for one day, because apparently it's good to get gum out of things. But if G sent for it, you write it down. Take it to the bank.
I like how much G knows about it.
When she did, she told me why later on is whenever she was in high school, they needed to get gum out of something, so they went to the chemistry teacher and he sent that back and it worked great. All right, so SI. There's a 2, so di.
Since it's not mono.
Silicon.
Silicon hexoxide.
Hexoxide.
That's a mouthful.
Whoa,
hold up. Hold up.
Hexa, who did what now? Thank you.
You can tell your major definitely wasn't an English.
Hexacide.
Hexacide. The new chemical spray for the plant. Hexacide.
Ask me if I care.
Also,
I feel like you should mess it up.
It's the new form of genocide.
All right, simmer it down.
It's not all.
That's the last thing I need being said out in the hallway about this class.
It's a
You guys have done such a wonderful job. I'm wondering if I'll be down for one chemistry class next year.
oh no.
Because every time somebody's like, yeah, take chemistry, you'll learn it. Someone, it's like out of nowhere, just pops up, it pops around the wall. Don't do it! Don't do it! I regret it!
I mean, other than the words, it's a pretty fun class.
Yeah. And the exception of the 5 that one chemistry. The 5, there's no blue this year. Mr. Hoss,
Yeah.
who was the 5th person in your second or your 5th period chemistry that wanted the chemistry 2 class?
Tricarbon nitride. And let's do the end of the day of all. Yes.
I don't know what's wrong with God, these are some mouthfuls today. Heptanitride. Whoa. Oh, I can say it.
Alright, so on this one, tricarbon heptanitride. Carbon, 3, nitride, and hepta 7. Then triarsenic is because y'all are having so much fun with that. AS for arsenic, tri is 3, fluoride is F, pent 5.
Fluoride.
Lab tomorrow.
Tomorrow.